Today, let's talk about the blockchain ecosystem. If you want to provide your users Web 2-like experience on an on-chain application, you'll have to hide a lot of complexities, starting from managing accounts, building a wallet infrastructure which is compliant, and sponsoring gas fees so that your users can feel seamless transactions, and doing all these at scale without breaking anything. See, this is where server wallets from CDP comes in. They let you manage accounts, send transactions, enforce policies, and also sponsor gas fee all via secure APIs or a few lines of code from using an SDK. And you don't have to worry about all these heavy lifting at all. In a previous video, we did walk through about how CDP secures a private key and how wallet infrastructure work behind the scene. If you haven't seen that yet, we highly recommend you to go watch it and learn more about CDP's infrastructure behind the scene. Cool. Now let's move on to the coding part. In this video, we'll actually switch to the coding side using official CDP SDK. They provide SDK in both TypeScript and Python. We'll be using Python in this video, but if you prefer TypeScript, you can find the information in the same documentation. All right, let's move on to the plan. So in this walkthrough, here's what we're going to build. So the first up, we'll be setting up the environment. We'll be installing CDP SDK, creating the virtual environment in Python and more. Okay. And then we actually go with creating an account and also importing an existing account using private keys. Okay. I'll show you that. And the next thing is sending a transaction. We'll try to send a transaction, fetch balances and more. And here comes the best part, attaching policies. We'll see how attaching policies will enforce your wallets to be compliant with your project level guidelines or maybe account level guidelines. And we have gasless transaction and smart accounts. We'll also see how easy it is to sponsor a gas and also create smart accounts and issue to your users. Okay. And at the end, we'll also look at some of the best practices to follow and what to avoid and what to implement. All right. Sounds interesting. Let's get started. All right. So before we actually move ahead with the code, we need a couple of things. This is part of the environment setup. Okay, so we need the API keys, the wallet secret and everything. So what I want you to do is I want you to sign up in the portal.cdp.coinbase.com. Okay, so you can get your own dashboard. Next up, we're going to move to API keys over here, the API keys that we see here, right? And then we create a new API key. Okay, and again, this is a secret API key. So you create that, we're going to give it a name. We'll just say Python demo, and then click on advanced restrictions, API restrictions, scroll down, and make sure you select manage modify policies. Okay, so basically this is important if you are trying to work with policies. Okay, make sure to use this and click on create. Okay, so this will ask you to complete two-factor authentication, okay, which I've already done, and then it will give you your API keys. Make sure to copy them because it's only one time view. All right, back to the code. Once you have your API keys, the next thing is the project setup. So in this project setup, I have a very simple setup here. The first thing is I just have an empty project. Okay. And then I use requirements.txt here to list out all the SDKs that we might be using here, like the CDP SDK, the Python.n, cryptography, ETH accounts, and so much more, few more. Okay. And then also have a commands.txt file here just for the video sake. Okay. Where I'm listing out all the commands I'm using, and these commands will also be available for you in the description to copy paste. Okay. The first thing is we'll be creating a virtual environment using Python, then activate that virtual environment and then install every single thing from our requirement text file. Okay, now moving on, we have an env example as well. So these are the envs that we need, and remember the the API keys that you copied from CDP dashboard, you'll be using this to copy paste. Okay, so we can just create a simple env file from the example file over here. Oops, there we go. So and just replace these values. Okay, so once you replace these values, we can start with the entire implementation. So here we are at the accounts.py file. All right, so this file defines the function to create an account for you, and here at the beginning of the function we're also importing a private key from the env as well. Okay, we'll be using this to import an account. Okay, and right at the beginning inside the function we have the CDP, and we're using get CDP client from the utilities, okay, to get the singleton CDP instance, and then we're going to do cdp.evm get or create account. Okay, this will, as the name suggests, it will create an account if it doesn't exist, or else it will just fetch that. Okay, and then give it to us with the name Alice. Okay, and we'll just check the errors for that, and then we're going to go to Bob. Okay, so we'll try to get the private key, verify the private key, and then get the expected address, the wallet address from the private key, and we'll try to import an account. Okay, so with the name Bob. And if in case the private key was already imported, let's assume that you're running this script for the second time, the private key is already there. In that case, we are going to get the account using the address, the expected address. You can still use name equals Bob here, but I'm just showing you the options. You can either use name or address. Clear? Or this will return the tuple of Alice and Bob. That's the entire gist of create account function. All right, now that you have your environment set up, it's time to jump into the code. The first thing we're going to do is just try to understand what is the boilerplate code we have here in the main function. Okay, so the boilerplate is nothing but wrapping the entire main function with async IO so that we get a non-blocking experience. Okay, since most of our functions are asynchronous operation. Okay, and the next thing is we'll go to utils.py. I have a code here called get CDP client. So this get CDP client will give you a singleton CDP client instance. So what is singleton here? It's a pattern where we use to reuse something. Okay, so basically in our case, we're initializing the CDP instance. Okay, and we'll be initializing this once, and then we'll be reusing the same initialization everywhere in the function. Okay, so what we're going to do is, instead of dumping every code in the main file, we're going to separate everything and then gather, or let's say call everything in a main function in a modular way. So it's easy to understand. Okay, since we have a separated functions, it's important to make sure that we're using the same CDP instance so that we don't just create multiple instances of it. Now going to our main function, accounts.py. So inside accounts.py, I have some implementation. So what this accounts.py will do is it will create your CDP account. Okay, so basically CDP wallet. So how are we going to do that? So we're going to use the same CDP client function that we're getting from the utilities. We can remove this timestamp, not required. Okay, so we're going to create an Alice wallet. Okay, so all we're calling is create account with the name Alice. That will give you an account. And let's say you already done this before. Let's say you're running the script for the second time. Now this will throw an error because the name with wallet with the name Alice already exists. So to handle this, what we're going to do is we're going to call this if already exists. Okay, in the exception, if it's already exists error, then we're going to get the account instead of creating with the same name Alice. Okay. Similarly, we can also import a new account. So what we're going to do here is we're going to import Bob private key. That private key is coming from your env variable. Okay. So we're going to get the Bob private key and we are going to convert that private key to address. Okay. So basically getting the address from that private key. I'll tell you why we need this. So same way here we created a new account, but here we're going to import an account by specifying the name same as here and also specifying the private key. Okay, now this wallet will be called as Bob. But what if this already exists? Okay, then we're going to do the same pattern where we're going to check the exception. We'll check if it's already exists error. Then this time we'll try to get it from address. So you can again try to get it via name equals Bob, but I'm just showing you an option so where you can also get it via name as well as the address. Okay, so very simple approach, right? Just 1 or 2 lines, you have the import account, 1 or 2 lines, you have the create account ready. Okay, now going to main function, we're going to import some stuff here. So first thing is we're going to import account, create accounts from accounts. And there are some couple more functions we're importing from utilities. We'll talk about the other few in a while. And then we're also importing send tokens from send transaction. I'll also talk about that in a few minutes. Okay, now that we have create accounts, let's implement them. So we're going to say await create accounts. We're going to get Alice and Bob in return, basically tuples. And we're going to fund Alice account. So what is fund Alice account? Since we're going to do the transaction, right? So we need to have some balance as well. So luckily CDP gives you a function to get some testnet tokens. Let's see how it works. So we go to utilities and then we see a function called fund from faucet. So what does this do? So this fund from faucet, I think this zoom is too much. Yeah, this is good. So we're going to use the same singleton function, get CDP client, and we're going to do request faucet. Okay. So cdp.avm.request faucet. So, and then we specify the address of the user, the network in our case is base Sepolia, and the ETH. So we need ETH token as faucet. So this will give you some testnet Ethereum so that you can pay for gas or send tokens, test transaction, and basically your operations. Okay. Then we're going to sleep for 10 seconds so that the transaction can propagate to the chain. Okay. So that's what we're trying to do here. We are funding only Alice address because we'll be using Alice address to initiate the transactions. Okay. And the next thing we're going to do is we're going to fetch balances. So before sending transaction, it's better if you have some insights on balance, right? So what is the balance Alice have, what is the balance Bob has, and everything. So what we're going to do is we are going to utils.py, talk about fetch balance. So we're using the same get CDP client again. Okay. And this is the only 3 line you need to fetch the token balances. So you're going to say cdp.avm.list token balances. You're going to specify the user address and the network. So this will give you all the list of balances of all the tokens that is held by this account. So if Alice has, let's say 10 tokens, Ethereum, USDC, and some other tokens, okay, every single list will be returned here. So to make it convenient, since we are working on terminal, right, CLI, right? So it's really good if we can actually format it, like say like Alice : balance, Bob : balance. So what we're going to do is we're going to check if the balance exists. If it does, we're going to iterate it and then just format it basically, and just console log it as ETH amount or Alice equals amount, something like that. Okay. Now going back to the main file, we have the fetch balance ready. So this will console log, the print in your terminal, and we'll actually send the transaction. So we say send tokens. So what is this send tokens? So if you go to send transaction over here, we have send token function. So the send token function, again, we're going to use CDP client over here, and we're going to call cdp.avm send transaction. So we're specifying who is transacting it, basically the from address, that is Alice. Transaction, basically we're using EIP 1559 transaction over here for transaction format here. We're going to specify the to address, that is Bob. Okay, we're accepting it as a parameter, Alice, Bob, and the amount. We're going to specify the amount. And you can see we're using something called w3.2way. So we are initializing web3 here. This will convert whatever the amount you enter, like 0.1, 0.2, 0.3 to way format. okay, so that the blockchain can understand that. Okay, basically V is a lowest unit in Ethereum. And we check the transaction hash, we print the transaction hash, and we sleep for 5 seconds so that the transaction can propagate. Then we return the transaction hash. Very simple stuff, okay, where if you just few lines of code, you're able to invoke a transaction, okay, from Alice to Bob with the name, with the network and everything. Let's go and also log the balance after the transaction. Okay, so balance after the transaction. Now, if I clear this and run this again, so this should log the address of Alice and Bob, fund the account for Alice, then fetch the balance. Okay, there we go. Alice and Bob log, address log came up. Then, okay, we got the before balance of Alice and before balance of Bob. Transaction was successful. Okay, so next up, we'll actually see how to create policies. Okay, so until now, what you saw was a normal blockchain operations where you have two accounts sending balance to each other. The next thing what we'll be seeing is how to set up policies so that you can enforce rules. Okay, so I'm in the policy documentation of CDP, and here's the field definition of policy. We'll be actually doing this policy on the CDP UI. I'll just show you how to do that on the UI side. It's way more interactive. And then attach that policy to the accounts. Okay, so you have a couple of definitions. One is scope, and it will define, is it a project level scope, meaning it will be applied to every single account you have created within your CDP account. And then is it account specific? Account specific lets you attach the policy for only certain accounts. Okay, and it depends on your requirement. If you have a global rule, use it project level. And if you have like a very simple rule, account specific rules, let's say some users are premium users, some users are free tiers, you can use account specific scope here. Okay, and the rule specifies what are the rules that you want to do, like restrict token balance, like, transfer to certain addresses, or restrict the amount of transfer you can do, something like that. So action specifies accept or reject, accept if it's greater than 2 ETH, or reject if it's lesser than 0.001 ETH, something like that. Okay, you have some operations like, do you want to enforce this while signing, or do you want to enforce this while sending a transaction, or basically some other transaction like this. It applies for both EVM and Solana as well. Okay, similarly, you have some more, you can just explore the documentation for more details on how it works, how can you do and everything, just to get some more details. Okay, so we're going to go to EVM policies here, scroll down a bit more to get some example configuration. I'm going to click on transaction limits. So this example says that the transaction limit enforced is 2 ETH. So you can send only lesser than or equal to 2 ETH. So we're going to copy this. Okay, copy this configuration and click on this dev portal to go to our portal. This will automatically sign in since I'm already signed in. I'm going to click on wallet, server wallets. Okay, wallets and server wallets. Policies. Okay, I already have a policy attached. I'll show you how to do that as well. Click on create policy. Okay, click on create policy. This will have some placeholder policy for you. You can also click on templates and select which one you want, like transaction limits or anything like that. And I'm going to make this as account level policy because I don't want to make this as a global project policy for now. I'm going to restrict this only for Alice account, but you can also keep it as project level policy. Okay, this will be sign EVM transaction. I'm going to just cancel this, get the code from here, add something modified here. So I'm going to just copy this, paste it over here. And you will also get this in the description, or you can just pause the screen and then type it out. Okay, and our criteria would be that you can only send a transaction if it's 2 ETH. If it's lesser or more than 2 Ethereum, the transaction fails. Let's see. Okay, you can click on create, but I already have it created, so I'm going to just copy the policy ID. Okay, make sure the scope is account. Then go back to your code. Okay, go back to your code and go to policy.py, create a file called policy.py. Already have a function for that, attach policy. So this will get the address of the user, okay, who are we attaching the policy for, and what is the policy ID. And what are we doing is, we are updating the account. So we're going to update the user address, update the account of the user with the policy ID. Okay, very simple, 3 lines of code. Okay, it's using the same get CDP client again. So now I'm going to call, okay, I'm going to import attach policy, and then I'm going to call the attach policy and attach the policy for Alice. So here I'm going to say the policy ID, add the policy ID over here. Okay, so what this should do is, this should attach the policy for Alice. So now let's try to do the transaction. Okay, got the Alice and Bob. Okay, so we got some error. It says unexpected keyword argument account policy. Oh, did I make a typo? Let me fix that. All right, from the problem. The problem was we'll have to pass it as a update parameter. Okay, where we are in compliant with the update account option type. Okay, before we're just passing account policy directly, which actually won't work. Okay, so you have to pass it this way. Cool. Now that we have it fixed, let's go back to main, verify if the policy ID we're passing it right. Yeah, everything is right. So I'm going to run main.py again. So this should log Alice account ID, my balance, and the transaction fails this time. Why? because we're sending 0.0001 ETH and it says policy violation occurred and the request is forbidden due to the violation of at least one configured policy. So this clearly shows that how the policy is enforced for your account. Okay, so Alice account has policy attached right now and she can only transfer the amount that is equal to 2 ETH, not lesser or not more. Okay, so moving on, let's talk about gas sponsorship right now. So the gas sponsorship is really amazing here. So let me show you how to do that. So we go to the same dashboard, the developer platform. Okay, so go to wallets. Okay, sorry, where is it? Yeah, go to base tools over here and click on paymaster. Okay, again, CDP platform, base tools, paymaster. Okay, over here you have something called configurations on top. Over there, select testnet in the drop down and you would get the paymaster URL. Okay, copy this URL or keep this dashboard open. We'll come back to this. Now jumping into the code, I've cleared out the main function that we had before with a normal EOA accounts and the policies attachment and everything. So now it's empty. So now what we're going to do is we'll learn about the smart accounts. Okay, so in order to enable gasless transaction, you need to create smart accounts for the users. So we have a file called smartaccounts.py. For some reason I have two files. Okay, so you can ignore the file with hyphen. I'm going to just delete it. Okay, go with smart accounts, smart_accounts. Okay, so here we have a function called create smart accounts. Okay, similar to create accounts. So here we're going to create an account for Alice and Bob, return Alice and Bob as a tuple. Okay, inside the function over here, we have something called cdp.evm get or create account. So basically we're getting or creating account that we used to do before as well, like we did in the beginning. And then we use that as owner. So basically for every smart account, you need to have an owner account as well. Okay, learn about smart accounts or account abstraction if you're not familiar with this concept. Okay, and similarly we just create or get a new smart account as well with the owner as well as the name. So here the owner and the account would be named Alice. Okay, and we're going to print out the address as well just for the sake of CLI. Okay, and we go to gasless transaction, learn about how gasless transaction work. So we have a function called send gasless transaction. We accept the from, to, and the amount and the paymaster URL. Remember the URL from over here, the paymaster URL. So this is what we get. Okay, so we get the paymaster URL and add this as a default parameter. So if in case you pass paymaster URL as a parameter for this function, that will be used. If you skip that, then this will be used. Okay, this is like a default parameter. Okay, then we initialize the CDP SDK and then we call user operation. So if in case of smart wallet, you have to call user operation instead of send transaction. Okay, so we're going to say cdp.evm send user operation. We're going to specify the smart account from which account are we doing the transaction, and then what is the call data. So we're encoding the to address, the data is empty here. 0x stands for empty data, and value is the amount of ETH we are trying to transfer. Then we specify the network, which is Apolia, and then the paymaster URL. Okay, so who is the paymaster for this gas? So basically who will pay for this particular gas. Okay, then we have user operation, wait for user operation. Basically we'll just wait until this particular operation is done. Then we just console log if it's successful. Okay, sorry, print if it's successful. Damn, JavaScript ecosystem. Okay, now going back to our main file, since we are now clear about smart accounts and the gasless transaction, let's start putting them together over here in the main. So first thing is we'll import those two, then we'll create smart wallet for smart Alice and smart Bob, smart boys. Then we're going to fund Alice account. The reason why we are funding here is, though it's gasless transaction, we have to realize that gasless is only for paying gas. Okay, so now Alice won't pay gas while doing the transaction. But since our entire transaction is about sending Ethereum, we need some balance. That's the reason we're getting some faucet funding. And then we're gonna again log the balance, print the balance, and we will actually send gasless transaction. Okay, we'll add smart Alice, smart Bob, amount is 0.0001 ETH. Now we'll print the balance after the transaction as well. Okay, so now the gasless transaction is ready. So we're going to open up the terminal, clear the terminal, Python main. So we will first get the log of Alice and Bob account. There we go, Alice account, Bob account. So both are different address now. Then we will actually get the funding from the faucet, which will also wait for a few seconds. There we go. We got the balance 0.38 ETH and 0.002 ETH. Then we are sending the gasless transaction, waiting for the sub broadcast. Everything is done, confirmed. And now we go. Look at the balance. Why is the balance same? Yes, the balance might be delayed here for updating. The reason is, if I show you the actual Explorer, the same Alice address as 37 right now, and you can see it says 38 here because might be delay with the transaction propagation. maybe we can add async sleep over there, like 10 second or sleep or something like that. That should work, but that's okay. And if you search for Bob address, you should see the difference over here, 0.003, and here it's 0.002. So bit of a delay, but the transaction went through and you can see the balance being updated as well. So the transaction was successful and we were able to initiate gasless transaction as well. And if you look at the structure in main, right, you can see the same pattern where we had before as well, like with normal externally owned accounts, like the simple create accounts. And the pattern was no different. And even to implement gasless transaction, all we had to do was just change send transaction to send user operation and just specify the paymaster URL, which was already available for you without much configuration needed from the portal. And this makes it so simpler when you're actually building application in scale, because you don't have to worry about the infrastructure at all. You just start building and shipping products, right? So this was about the hands-on coding. And let's talk about some more about the best practices now. Okay, one of the most important aspects of CDP wallets are security. Though CDP gives you state-of-the-art secure infrastructure, there are some things that you have to handle it by yourself. First thing is, make sure to load every sensitive detail such as API key, wallet secrets, all these things via environment variables, or inject it some other way, secure way to your production servers. Do not hard code it anywhere. And the next thing is rotate your secret keys. Okay, you can refer to the documentation how to rotate wallet secrets here. Rotate your secret keys regularly. Maybe for every single deployment, keep rotating your keys, or within a given specific time, like once in a week. And please set up 2FA to your account if in case you're moving to production and if you're using your company's account or organization's account. Please make sure 2FA is set up over there so that you don't lose access to your account. And at last, make sure every single logging you're adding over there, make sure it doesn't involve any sensitive details like logging the maybe ID of something that's sensitive, or API keys or wallet keys or something like that. Okay, make sure all these are basic things are taken care of, because CDP cannot give you 100% security if you're not doing your part. There are some more additional features that server wallets offer you, and which is more beyond than what we just built. You can still come back and refer to the documentation regarding those things. And these may be optional but really powerful, and these might help your application to scale and tap into different use cases as well. So that's the walkthrough of server wallets with Python SDK. We've seen how to create wallets, how to fetch balance, how to tap into faucet for funding, how to send transaction, how to create smart accounts, how to enforce policies, how to enable gasless transaction. Okay, don't forget to check out CDP documentation for more details. Not only wallets, they have some more other services which might be useful for you. Everything is managed within CDP platform. And do not forget to follow Heimlabs in all the social for more such tutorials and updates. Thank you so much.